take it
This
away.
conference will now be recorded.
And we will need to save just a few minutes at the end because we need to schedule out sort of the next couple of calls.
Okay. Alrighty, so let's see, who is on today? We have a lot of people, okay. And Joe, I'm glad you're on too, because I have some questions. So one of the things, a minor thing in the sort of an editing nit is to put better references into this diagram and link it better with the text. And I've not heard from anybody in microsemi, so I assigned Jeff a thing to do. Maybe that might work. I need the source to this, or I'll just have to recreate it if I can't get a hold of him to get the source to this diagram. So that's a nit. Moving on to, I've updated some of the diagrams. Let's see. So after talking with Zhao Yu from Intel, I realized that there are different schemes for doing the initial device identity credentials. How do you get the certificate into the device for its own identity? This is not ownership. This is what is the device and who provisioned it or who made it in other circles. So this diagram hasn't changed, but I'll go through it just because we can compare it to the next one, which is new. So in this example, in this diagram, the device shows up, I'll use manufacturing floor, but because it's just easier for me to understand, but it's really provisioner. So it shows up on the manufacturing floor, it generates its own unique device secret. It uses that secret into a key derivation function to generate its own key pair, which is the ID, the device ID key pair, private and public. It stores that in its protected storage. The private one has to be read and write protected. The public one is write protected. It has to remember those unless it can just simply store the seed and keep regenerating it every time. That's another option. It sends that to the provisioner's CA, who signs a certificate over that public key, the device ID public key. Sends it back to the device, and the device stores it in its non-volatile storage. And the provisioner can optionally store that in a registry of some kind. Everybody with me there? All right. So here is the Intel version of that process. Well, I don't want to make it too small and then not be able to see it. Okay, and so you keep me straight here. So in the Intel version, there is the provisioner and the attester both use a seed that they both use to recreate the key pair, and they both and the X509 certificate can essentially be generated in advance, because knowing the seed and knowing the KDF, the provisioner can create it as well as the device can create it. So we start out where the provisioner in this case generates the unique device secret. Then it uses that UDS as input into a key derivation function, and therefore creates the device ID pair. Then what's next is the provisioner needs to create a certificate for that key pair. So it creates a certificate over the public key, signs it with the provisioner's private key, and then at that point it creates a template where I'm not sure in the Intel case if you remove the device ID, but at some point you've got to have the whole intact certificate to be able to sign it. But the public key can be removed from the certificate. We'll keep going in case I didn't understand this. Then it sends that to a registry with the template and the seed. And that sits in a database somewhere until after some time passes. The attester device, which doesn't know who it is yet, right? It's just a blank device. It comes up on the factory floor, and the registry, the information from the registry is pulled out and sent to the device and says, here's your unique device secret, here's your seed, here's a template for you to fill in for a signed certificate, but it's missing the public key. The device uses that seed as input to the same exact KDF that the CA used. So it will end up creating the same key pair. It plugs in the public key into that template, and then stores it just like the other one did. It stores the private key in read and write protected storage and the certificate in write protected storage. So Zhao, you
Just a
get
small
it?
correction. It's mainly correct. What we provision is not the doesn't include the template. The template is something we hard code in source code. What we provisioning
Okay. Yep.
what we
Okay.
provision is the seed plus the signature on the certificate.
Got
That's
it.
the only two elements. Yep.
All right. So it's just the signature, not the whole thing. And the template is already hard coded in the code.
Right.
All right. Thank you. I missed that. Yeah, I was wondering why do you, so this part, this template is there, but it's not signed because you don't have the signature yet, but it's the signature that will come in to be filled in the template. This value here is a signature, not a template. Right here,
Right.
this arrow.
There are some small tricks there, right? The template contains many fields, not just the subject, public key, and the issuer signature. For example, the serial number and valid dates, etc. All these are either hard-coded or derived from the public key. For example, the serial number, we define that to be a hash of the public key. So we have some hard-coded values there or hard-coded rules there, so that all the device needed to reconstruct the certificate is the seed and the issuer signature, nothing else. So we can
Okay.
consume a minimum number of fuses, which is expensive.
All right. So where is the serial number getting generated and how does it get into the certificate?
So we define that, for example, we can use the serial number. We use the hash of the public key as the serial number.
Right. But who's using it? The provisioner or the device?
They both, right? They have the same rules to create a cert. And the rule is for serial number, use the SHA-1 hash of the subject public key as the serial number.
Is that inserted into the certificate? Is it
Right.
signed? Okay.
Yep. And for example, the valid from and valid until dates, not before and after dates would be pre-agree between the provisioner and the device. Just a hard-coded value.
Okay. And that's also put into the certificate?
Right. Not before and after are the two fields in the S5 certs.
Okay. So it's pre-agreed. Good. Okay. I will fix the diagram. So, are there any comments about putting this in the document? Were you okay with putting the Intel model in there? It's an option. The only thing that is a question to me is having the seed done outside of the device, but all of this has to be done in a secure environment anyway. Brian is on. I would expect Brian to comment on it, but nothing.
I'll ask a question. Does this preclude self-created secrets, or is it an option here?
It's an option. Yeah, we are thinking about it as well. But that requires the signature facility to be placed on the manufacturing line. So the architecture would be the device generates the seed or UDS on die using PUF or DING, and during the sort or class testing, the device generates the certificate and output that to the signature service, the signing service. That would have to be on the class test manufacturing line, and then the class tester would burn the signature back to the fuses. We don't have that infrastructure yet in our manufacturing line. So yeah, that's a future plan, not now.
Okay.
What do you mean, like a future plan, not now? Shouldn't that flow be in plan?
From the standard perspective, yeah, you can include that flow as well. I'm just saying we have that in our vision, but it's not implemented yet.
Yeah, so the other way is where the device generates it. And then, as Zhao Yu said, you've got to have this certificate signing operation done in manufacturing, because that's when you finally know the UDS, right? And the keeping.
Right.
And if you don't have this facility, I mean, that's an exposure, particularly when you have other vendors doing this for you, right?
Yeah, I don't think you get to know the UDS, right? That stays in the part. But
Right.
There's a point in time when you're doing your silicon verification and you go, yes, this is, you have the proof. That's your deepest examination of the part, and you say, yes, this is a genuine part that I manufactured, and it's given me out this. Really, it's a certificate. You don't know the origin or the entropy behind the key. You don't have knowledge of the private key, but at that juncture, you're trusting the device and signing the public key.
Yeah, which to me in the Intel model, it seems like you've got to double check there. I mean, you have a checks and balances, because then you've got this device has to come up and match what your certificate step created, right? It's got to, otherwise it's not going to match the certificate that was generated for it.
Right.
So what is the question? What parts should be done in the device compared to what parts should be done external to the device?
Well, I don't know. I guess the question is, do we want to, are we okay with having two models? I think, in my opinion, we've got to, because this is the state of the world, right? We can suggest things. This is how you do it. If you don't have your CA in manufacturing, this is a good way to do it. I mean, what else can we do? This is what the state of the world is, and we want to recommend do it the best you can, right? If we had our druthers, it would be this way, I think, right? But you still have to rely on, it's still not perfect here either. Neither one is perfect, because in this model, you have to rely on this provisioning step and the connection between these two, this tunnel here between the device and the provisioner. All that has to be secure. And in the other model, this whole generation of the UDS and the injection of it has to be secure. So, you know, it's half of one and we half a dozen and six of the other. So if everybody's all right with it, I'll just leave it in there. I'll fix the document, fix the diagram, and leave it in there.
The second step, this like the generation of the UDS is like happening offline,
Mm-hmm.
and you're
And
giving
this one, yeah.
you give apart the seed and the UDS.
Yes.
And how do you know you're giving it to the right thing?
You've got to do it. Go
And
ahead,
it's-
Ken.
What do I mean right thing? Meaning it's not corrupted or what?
No, you're giving out certificates, essentially, and entropy to go and generate the keys. It's the same as the problem with symmetric keys, right? How do you bind it to a specific device? So if I'm a man in the middle and I get this time passes and I'm at this, like, here's the UDS and here's the X509 certificate, and somebody receives those.
So what's the question?
How do you secure that step, that device registry step?
After time passes.
At the time passing, during that time, how do you secure that step? How do you prevent leakage of the UDS?
Yeah, this all the internal. Yeah, so the key generation facility and the manufacturing, they have secure servers that make sure it's secure. Plus, one additional step is that the UDS is encrypted using some a key, which is in the device RTL as well. So that's just additional step. It doesn't.
Is that a metric key, or is that the public key is in the device, and then each device gets that? Is it a global?
No. Yeah, it's a global key. But it's that's an additional step. I mean, it's a global key, so it doesn't give you a real robust security. But yeah, we have to make sure that the manufacturing is secure, just like in the first cases.
That's tough. Well, in the first case, it's different, right? Because you're never exposing the entropy. In the first case, the device has that. So what you're doing is, at that point of provisioning, where you've checked the device, you've ran through whatever tests you did to verify that that part is genuine when you get it back from your fab or wherever you're doing your ATE, and then you're taking the CSR. And it doesn't matter if somebody compromises the CSR, if you lose the CSR, if you never check it into the database, because it only contains public information. And the only thing that can decrypt anything that's encrypted with that public key There's that actual part that you physically verified and said, yeah, this is my part. I'm going to take this PSR and import it into my database.
The problem with the first case is that the signing service never know where that device IK pub come from. It could come from a malicious generator, not your device. How do you verify it's coming from a valid endpoint? No way.
Yeah, you're the one doing the verification, right?
Who does the verification? The provisioner has no way to verify where that device IK come from, right?
Yeah, that's right. Because it doesn't, it hasn't gotten its its birth
So you could sign
certificate.
anything.
Yeah, it could be a software clone, right?
So it's pros and cons on both methods, right? It's you need to make sure this is secure as well, so that the provisioner doesn't sign arbitrary request.
Yes, it does have to be secure. There are additional checks and balances that you have to have on the end. For example, you'll have to be, auditing other parts like your manufacturing bills, your quantities bill, serial numbers, etc. So the difference is you're not giving out your entity. Right?
Yeah, if the provisioner is not super secure, you're not giving out entropy, but you can create your own entropy and have it sign, which is the same. You don't have to steal entropy from a legitimate device. You can just create your own entropy and have the provisioner sign.
Yeah, you're saying you could have some other, a clone device, whether it's hardware or software, and you present that to your provisioner to get certified.
Yes, as good as a good one. Why do you need to steal others' entropy? You create your own entropy.
Mhm. Yeah, this has to be done securely as well. This, because we don't have ground to stand on yet until we get through this, right? I mean, you could have, like in your case where you've got a shared key at this step here, what you're saying is this tube, this pipe here is protected by a shared key hard coded in the device.
Actually, not here. This bypassing the device registry. It's from the provisioner and the device. So the device registry is a middleman. It doesn't know anything. No secret is exposed to it.
Okay. Yep. Yeah. So that's one. Right. So this tube, this pipe, really extends all the way back to the provisioner. Yes.
Right.
This pipe. Okay. Yep. It just goes through the registry, but it doesn't. And neither does, so this is wrong here too, because we don't trust the registry in your case, right?
You just put a cylinder on this one, you'll be right.
Yeah, okay. All right. All right, well, unless I hear some big objection, whatever, we'll keep going. All right, and we need Wojtek for this one coming up here. So this is the modified, a slightly modified diagram. He sent me the source. And this is in the ownership, in trying to establish ownership, there is a model here where the device, so the one we just now talked about was this device, right? This is the device's identity key. It says, this is who I am. It has call it a birth certificate. All it says is who made me, or who provisioned me the first time. It's not an attestation key that it's certifying, it's an identity key, right? It says this is who I am, but it's not used, that key is not used for attestation. A key that is used for attestation can be generated by the device. Let me go back to, hold on just a second. Let me go to here. All right, what we're trying to do is have the device generate its own attestation key pair and get a certificate on that. This is why we came up with where we had a problem last time we started discussing it, which is how do you get a certificate across this attestation public key? Who's going to issue that certificate? One possibility was the device issues it itself. Another one is the owner issues that certificate. So in this model up here, the device can issue a certificate over this. Oh, this is an AK. Sorry, shouldn't be an IK. This should be an AK. Over this alias certificate or the attestation certificate. And then later, the owner comes along and says, I'm going to issue a certificate over the device certificate. Where I'm running into trouble is there are different things. One is the device at some point needs to know who its owner is, because later when the device is going to be presented with firmware updates, it has to know who to accept them from. So first question is, where does the device, how does it remember the owner's public key, its owner's public key? The second question is, if we're using this certificate to say I own this device, then this is a certificate, this is a signature over an identity key. The owner's key in this case is signing or issuing a certificate in this picture over the identity key. So the owner's key is used to sign a certificate, not sign code. And we have to keep our key usage separate. We can't use a certificate signing key to sign code with. And now I'm seeing an explosion of keys and certificates because I see that we need it's getting nasty, like 3 or 4 certificates on this poor little device, because it has to know who its owner is from a point of view telling the world who its owner is and accepting firmware signatures. So we're at least up to 3 certificates, and that's troubling me. So Wojtek, can you please explain what you
Sure.
intended?
So in this simple model of this ownership claim, it isn't quite intended to also function as the firmware authentication provisioning, or firmware authentication key provisioning. Essentially, it can be morphed. I think it can be morphed into that, but I for this, because at least in case of Intel products, we may end up going with like double signature verification of both Intel and the owner, but I'm pretty sure that we're always going to enforce Intel signature on the firmware. We kind of propose that essentially this ownership claim of the device doesn't impact the behavior of the device and how it loads its firmware. And if we kind of make that assumption, then this can be very simple. Those slots can be unprotected because they're essentially only used for attestation. And they're only used, essentially. And if you see that the slot has stuff that you were not expecting, then you already know that someone has been tampering with it. Right? So from attestation point of view, this can be extremely simple and very permissive, essentially. Other than the slot 0, which is essentially mutable, all of the other slots, the device doesn't have to protect, because the platform should ensure that only the authorized entity can put stuff in there, right? And that this way, essentially, it's very simple to use. It gives you, good usage for the attestation, and essentially making sure that this is a device that you have taken into your data center through your flows, essentially. But provisioning of any information here doesn't change the behavior of the device. And this is kind of because our some of the features that we're working on for like double signing are provisioned differently, usually through some debug accesses, rather than just in-band or for like MCTP, where we could provision this stuff. So that's kind of the reason why this is the way it is, essentially. And you have here the on-device, off-device. At least in some of the devices, like for example the SSDs, our thinking is that all of this would be on the device. That essentially the device will have storage to keep all of those certificate chains, so that it can always present it from the device itself. Now I think that if we wanted to kind of put it together with the double signing, then I would imagine that now the slots would need to be protected by the device, and information put in there would need to be authenticated before it's written to those slots. And then in the somewhere in the model cert, you may have a extra field that says, by the way, this is your model public key double signing key, essentially. And that could be an option to kind of marry both ideas together, where now the provisioning of this data, and you not only take the claim of ownership of this device, but you also tell the device that from now on you should boot your firmware by checking both your manufacturer's signature but also my signature over it, right? But it will then become more complicated, and I'm always a little bit worried that if we make it too complex, then the adoption is going to be essentially is not going to be there if we make it too complex. Which is why kind of the original proposal is to keep it very simple, very permissive. Provisioning of the stuff doesn't change the behavior of the device.
So there are two. I'm confused about the incoming and outgoing. So from the need to have an owner model cert there is, I would think, for outbound, right? Because you want to tell the world who owns this device, right? To station. Yeah.
Yep.
Okay. But then for inbound, where do we put that? Where do we put a different owner key?
Sure. So in I don't think that right now we have the double signing necessarily in some of our products. No, we're working on some of that stuff, and essentially for that double signing key, We just have some extra storage elsewhere attached to like a local root of trust of the device. No, that has space, protected space essentially to store the owner keys that can be provisioned through other means than this essentially.
So then this, I don't know if you can see my cursor. So we would need this to be on device here. And then we need another one for the owner's firmware signing key, public key.
Yes. So today that's kind of the thinking model that no, this is only for this ownership like claim, right? And it but doesn't impact the boot. And then if the device supports double signing, then essentially there is a separate way of provisioning that signing key or authentication key rather in a special place essentially that the device will protect and it will use for this authorized for this double signing boot, right? If like and like I said, no, we could potentially marry them together and have an extra field in the X509, some extension that says, by the way, this is the model cert that signs your device cert, but it also gives you the information of what is the public key for firmware authentication, right? Because you could probably come up with an extension to the X509 to convey this information.
So you could
but like I said,
you could put two keys in one cert.
Yeah, essentially you could put the key like the model cert public key, to essentially there's the public key information in the X509, right? And that would be the public key for the model cert. But you could essentially create an extension that says, by the way, this is your firmware signing key. If this is your firmware authentication key as well, and then have some separate key that serves that purpose. But then though this slot needs to be protected, and today we don't really have any means to protect access to those slots. I know that DMTF, for example, they're pushing more to have those slots protected. I think personally that will make it too complex to use, and those slots will end up just not being used in the future if this is too prohibitive to provision stuff in here. But those are kind of essentially two different thinking models about those slots, and I think that making them permissive is better for usability, and it's perfectly fine for attestation purpose, for that kind of outward use, right? But yeah, it won't be sufficient for that inward use if we want to use this also for the firmware authentication.
Right. Yeah, we need a place to protect that firmware authentication public key.
Yeah. Because otherwise essentially someone could just come in, change this stuff, and they would then, although technically, now that I think about it, since for at least in the case of our devices, we will always check the manufacturer signature, which means that it's not that you can provision, you can put in your own firmware in there. It's only that you authorize that the firmware that the device is running is something that you have qualified, right? But you won't be able to really write your own firmware for the device. And in that case, as long as the firmware provides you attestation and information of what keys have been used to authenticate the firmware during attestation, then maybe this can still remain permissive. And if someone comes in here and provisions something else and some different firmware signing for firmware verification keys, then as long as it's only used as a second level, maybe that's good enough. However, I would imagine that that could, for example, be then exploited to like denial of service, right? Because you have your firmware of that you have double signed by you, and then someone comes in and either like clears out this cert or put some garbage in there, and then the firmware that you have residing on the device would not load because it would fail this double signature. So there are some caveats here, right?
Yeah, I think we'll have to support multiple models too, because in some devices where, for example, they might be manufactured on behalf of another company, those just replace the whole, the one, the OEM who ultimately is responsible for the thing becomes the owner, but the one who manufactured it in the first place puts all this on and then gets out of the picture, right? Goes away. And they don't double sign, they just go away. But the owner stuff takes their place. But it has to be able to.
I think that in the end we may need to kind of like combine some of this with the white paper that you wrote about the ownership transfer. Although, like I said, in many cases, that initial manufacturer firmware verification is not going to really go away, because I'm sure that there are going to be some companies that will be okay with that, where they essentially they relinquish the firmware signing completely, right? And you're the owner now. You own the whole thing. Yep. But at least for Intel, and I'm sure that for some other devices on the market. We got some echo. But I'm sure that at least for some other devices on the market and some other device vendors on the market, they won't really be okay with that, and they will always go with, at best, the double signing capability. They won't really relinquish their signing capability. So I think that some modification of the ownership transfer that you have written down, and kind of marrying some of this with that may be needed in the future.
Yeah, I'm wondering if we should make, like, we'll get rid of this one for the moment, where in the simplest case, we've got the manufacturer, provisioner, we've got the owner, and then we have owner for authentication, and we have the owner over here for attestation, where the one for authentication is protected, but the one for attestation is not.
Yeah, that could be essentially make a very dedicated slot for the firmware verification, right?
Yeah.
And then that slot would need to be well protected, and probably would need some kind of essentially follow the model that you scoped for the firmware ownership, in which case, like, the manufacturer would need to essentially sign some message that, or some payload that you would then put into the device, and the device would use the manufacturer keys to authenticate that the manufacturer authorized the owner to claim this double signing, right? For example, or just make it first come first served, and then only person who already owns it can change it, for example, right?
Yeah. Yeah, it would fit those models that way.
Yeah. But that could be a good compromise, essentially, to have a dedicated slot for that, and then have the permissive slots for attestation.
Mm-hmm. Yeah. All right. I think I will do that. It's tough because we're starting from nothing, right? Today in the industry. Yeah. Or, what we've all cobbled together for our own solutions, and trying to make it fit and still be reasonably secure.
Yeah, and the other part is that sometimes we think that this really has to work this way, right? And then you go to the business people and they say, well, and now you made it so secure that I cannot use it anymore, right?
Been there, done that. Yep.
A question. Does the owner's certificate has to be signed by provisioner by any chance? And a slot
So this
1 has to be signed by slot 0.
no, so the permissive model, it doesn't. It's essentially you got the device, you use the slot 0 to authenticate that the device is genuine, and then essentially you can just put in whatever you want in slot 1. That's in the permissive model, which the attestation kind of model, which doesn't impact the firmware verification. And this way, essentially, once so you kind of do this when you onboard the device, and then in your production, you would always default just checking slot 1. You can ignore slot 0, because once you know that this is a device that your CA had endorsed, then you don't really care about slot 0, right? And if you see, for example, that the slot 1 doesn't have the information of your CA, then you know that something is wrong on the platform and someone has been tampering with it. So that already gives you an information about the device and about the security that it needs some audit.
There's nothing preventing anyone from making the attestation more secure as well, right? You could be less permissive.
Yes, you could be less permissive. My only kind of argument for being more permissive by the device, at least, is that it's then very easy to use by the platform owners, and it's kind of on the platform to make sure that you don't mess up with that slot 1, right? So, for example, there's a path to update this both in-band for, like, if it's a PCI device through PCIe, or there's a path to update this out of band, right? So essentially, on the in-band path, your hypervisor just needs to make sure that you restrict write access to this, and on the out of band path, your BMC shouldn't be putting garbage in there, right? And if any of those happen, then you know that you have a serious problem either with your hypervisor or with your BMC. If the slot 1 has been compromised. But kind of my point of view is that the device shouldn't be worried about protecting that slot if it doesn't impact its own behavior.
Yeah. All right. Well, those were my questions for today. It's been a very helpful discussion for me to keep this moving forward. And Mochek, you will be here the next 2 weeks, right? Next 2 calls.
Yeah, I'm not going to be here next call, and I'm not yet sure about the call in 2 weeks.
Right.
There's probably going to be another person dialing in from Intel in my place.
And when is Memorial Day? Oh, but that's all right. It's a Monday anyway. It's May 27th is Memorial Day. So Nate, back to you.
Cool, thanks. So, Elaine, do you want to keep going next week, or do you want to wait until Watch Tech is back?
Let's see. I'm just thinking of what can we go through if I do go forward. We can go back and make sure I correct this thing properly. I don't want to go through ownership without WCP on. And just scrolling through here, trying to figure out what else we could do. One place we have not done anything about is this discovery protocol. Another option is to go through the DMTF again, if somebody else wants to go through that, to see how we're stacking up against that. And I think, and then this is all pretty stable. I think we don't need to do much here about the attestation piece. It's pretty well done. Oh, I had a question here. Oh yeah, because we have the DTMF stuff or DMTF. Zhao Yu, did you want to make a comment about how that's going to feed into?
All right. Yeah, the symmetric authentication and attestation would be covering DMTF 1.1 spec, the SPDM, security policy and security protocol and the data model. 1.0 doesn't have this symmetric or spiral way of doing attestation. And I've been working with the DMTF team, and they're going to release 1.1 probably in June or July, and that will include additional commands for both the symmetric authentication and attestation, aka spiral, and also a pre-shared key version of authentication and attestation. The pre-shared key option means that we don't require the tester to have asymmetric key cryptography or S-File9 cert, but it will allow the tester to be provisioned in a trusty manufacturing line with a pre-shared key that's pre-shared with the platform. So that's very helpful for low-cost devices that do not have ECC or RSA capability. And that'll be added in DMTF 1.1 as well. Not sure about Elaine, you want to add that option in this OCP spec as well, but that will be supported by DMTF.
Yeah, so the question is, well, how do we converge the two? I see us getting way, I hope we're done by, say, 4th of July, right? We seem to be finally converging and getting close to the end here. So do we just leave this out of the first one and then add it to a second draft? Or do we hold it back until we finish the DMTF? It seems like an important thing for the less powerful devices, right? To be able to do that. We want acceptance, not, people throwing up their hands and giving up because they can't do it.
The 4th of July deadline is a hard deadline, or where does that come from?
My head.
So if you have a major holiday and set deadline.
Yeah, we don't have a hard deadline yet.
No, we don't.
Yeah, let's sync with the DMTF. I think the pre-share key option, Elaine, we should consider that even more seriously than this spiral version. Spiral version will speed you up, but will still require the asymmetric key cryptography on the device for the first boot. The pre-share key would completely eliminate the asymmetric key cryptography from the device. But the trade-off is in the trusty manufacturing line. I think that may get very wide deployment if that's supported.
Yeah. Well, then, I don't know, Nate and Brian, it seems like it behooves us to wait, but maybe we can do everything else and just put a hole in there and say, fill in this when we haven't.
Yeah, that sounds good if we can sort of get everything else around it done, and then hopefully at the end what we have will be very close to what DMTF releases, and it won't be a big change to sort of sneak it in. Do we have a sense for how different the DMTF scheme is from what we already have here?
Yeah, we have draft of the DMTF 1.1. I'll share offline with Elaine, and yeah.
right? But we can't publish it in here, right? Not yet.
Right.
Right, but I guess you and I could draft it anyway and then just hold it back until it's ready.
Yep.
We both know how to use this sequence chart generator so we can get it done.
Yep.
All right. So back to Nate's question about what do we do then in the next 2 weeks. I think I don't need to say anything or do anything in the next 2 weeks.
All right. So what other sections haven't been presented in a while then? Going back. So I know Brian said secure boot. He had all of his final questions answered. Is that correct, Brian? Not sure if Brian's still on. Yeah, just quiet. Yeah, so I'm trying to look for other categories that do not involve Logitech, and it turns out there are not many. The recovery of trust was one of the things that we covered back at the very end of last year that Adrian and Logitech were working on.
I can try to chase down Adrian and Shrikant and see if they have any updates on that one, so they could fill up a slot. I will send them an email.
All right, great. And then other than that,
You know what, Nate, we might consider is talking about certificates again in the context of where are we, what code has to process them, what components of any system have to process them, what has to generate them, what has to sign them. We could, given that we have the attestation protocol diagrams almost nailed down, we could go through those and say, okay, this is where the certificates either have to be interpreted or they have to be generated, and make sure that we just double check that the places we expect to use them or generate them can actually do that. And I think we need Shrikant, right?
that could work. That'll be affected by the DMTF protocol, though.
Yeah. Well,
so if that protocol is sort of subject to change, we'd just be redoing it again after we change it.
well, the symmetric ones, not the asymmetric algorithm ones. What about algorithms themselves? Are we going to be that? Oh, that's another thing we could do, Nate, is just, get in fist fights about what algorithms we should support.
All right. Yeah, we can schedule that for next week. And while we also try to track down Adrian for updates.
Yeah, and you know how we can go through the algorithms is I have that key table. Well, I'm not presenting anymore, but the key table at the very beginning of the document on page 5, where I list all the keys. I have no idea what to put for algorithms. I just put question marks. So we could go through, it's section 7, where there's a big key table. So why don't we put that as one of the days, one of our calls is section 7. And we'll see how many question marks we can fill in.
All right, I'll put that down for next week.
Okay.
And then I guess in 2 weeks, I'll sort of pencil in Adrian for updates if he has any. If not, hopefully find out relatively soon and find something else to go there.
All right, and then put me in for the 3rd week, right, when Wojciech is back.
All right, sounds good.
Great. Thanks, everybody.
All right, thanks everyone. Have a good week.
You too. Bye-bye.